Alright, let's consider this series, the sum from k equals 1 to infinity of negative 1 to the k plus 1 times e to the negative k times k squared plus 4. We want to know, does this series converge or diverge? Now, just looking at it, this series looks like a mess. And sometimes when there's a lot going on with your series, trying the ratio test can be really helpful. So let's use the ratio test and see how it helps us determine whether the series converges or diverges. So recall, for the ratio test, we want to look at the limit as k goes to infinity of the absolute value of a sub k plus 1 over a sub k, where again, a sub k is just this expression right here. It's the kth term in our series. So, this limit becomes the limit as k approaches infinity of the absolute value of a sub k plus 1, which would be negative 1 to the k plus 2 times e to the negative k plus 1 times k plus 1 squared plus 4 all over negative 1 to the k plus 1 times e to the negative k times k squared plus 4, and we have the absolute value. Now, what does the absolute value do here? Well, in this case, we can get rid of the negative 1 to the k plus 2 and the negative 1 to the k plus 1. All the other components in this expression are positive. And so this limit just becomes the limit as k goes to infinity of e to the negative k plus 1 times k plus 1 squared plus 4 all over e to the negative k times k squared plus 4. And let's do a little bit of simplification here. This becomes the limit as k goes to infinity. And now e to the negative k plus 1, I can rewrite that as e to the negative k minus 1. I just distribute the negative sign. And my k plus 1 squared plus 4, when I expand the k plus 1 squared, right, I have to FOIL. And so I get k squared plus 2k plus 1. That's the k plus 1 squared. And then I add 4 to that. And in my denominator, I'll just leave that as it is. So e to the negative k times k squared plus 4. And now, actually I have e to the negative k and e to the negative k minus 1. So my e to the negative k will cancel out with that e to the negative k, and I'll just be left with e to the negative 1 in my numerator. And of course here I can simplify the k squared plus 2k plus 1 plus 4. The 1 plus 4 just becomes 5. So, let me rewrite this. We'll have e to the negative 1 times k squared plus 2k plus 5 all over k squared plus 4. And I'll do one more step just so we're very clear on what this limit is. The e to the negative 1 is a constant, so I can bring that outside of my limit. So I have e to the negative 1, which is just 1 over e. Right? E to the negative 1 is 1 over e. Times the limit as k goes to infinity of k squared plus 2k plus 5 a degree 2 polynomial in the numerator and in the denominator, and both of my coefficients on k squared is just 1. So this limit is 1 over 1 over 1. And so I just get 1 over e, because I have 1 over e times the limit. So now we did the ratio test. So the ratio test tells us if this limit, the limit as k goes to infinity of the absolute value of a sub k plus 1 over a sub k, if this limit is less than 1, which 1 over e is less than 1, then we know that this series converges absolutely. But we know that if a series converges absolutely, then it converges. So therefore, this original series that we started with sum from k goes 1 to infinity of negative 1 to the k plus 1 times e to the negative k times k squared plus 4 converges, and it converges absolutely by the ratio test. So one quick comment about our work here is this series is an alternating series, but we used the ratio test to show that the series converges. So just because we have an alternating series does not mean that we have to use the alternating series test. In this case, it was much easier to use the ratio test.